Good afternoon, Geometry. All right, so this is a continuation of our lesson from yesterday. So yesterday we just barely got our feet wet with the segment addition postulate. We've done a couple of measuring things. And so now today we're going to really get into using the segment addition postulate to solve problems. Okay, so take a look at our target here. So by the end of today, you want to make sure that you first of all know what this segment addition postulate is. And then you're going to use it and the definition of a midpoint to solve for lengths and segments. Okay, so please make sure that this is where we end up by the end of today. Okay, to participate in this lesson, you will need your 4-1 packet from yesterday. Don't worry if you forgot yours, then I left some extras with the substitute. Just ask for them, please, and follow along with the problems that are in it. Okay, please make sure that you write down what's going on and you understand it. This is a video, so you do get to pause it if you need to and work on things. So please make sure that you maximize your learning. All right, so here we go. Okay, so first of all, so this is where we left off on question number 5, and we were using the segment addition postulate and the given information to complete these statements. Okay, a reminder, the segment addition postulate says that we can add two smaller segments together to get the length of the bigger one. It was kind of one of those more obvious results, which is why we called it a postulate. Remember, a postulate is such an obvious statement that it doesn't need to be proven, as opposed to a theorem, which is a statement that does need to be proven. Okay, so segment addition postulate, I can add two smaller pieces together to get the bigger one. All right. So our first scenario is if B is between C and D, and BC equals 10 inches and BD equals 3 inches, then what is the length of CD? Okay. Just as a quick side note here, notice that I'm leaving the segment symbol off of these, and that's okay. All right. So if I put the segment symbol above these, that means that I'm talking about the actual segment. If I take the segment symbol off, it means I'm talking about the length of the segment. So in this case, I am talking about the length of segment BC. So it's okay for me to leave the segment symbol off. Okay. For these problems, I always, I'm going to stress this, recommend that you draw a diagram, please. Okay. When you draw that diagram, it becomes so much easier to see what's going on and what I gave you and what I'm looking for. Okay. So let's go ahead and draw this. So we clearly have 2 points that are on a segment like this, and point B is somewhere in between them. We don't know where. Okay, so this would be point C, this would be point D, and this would be point B. Okay, we were given that BC is 10 inches, so that works out. So because that would mean that this right here is 10 inches. Okay, and then we also know that BD, so that would be this little part right here, is 3 inches. So obviously my diagram's not drawn to scale. That's okay. So look at what we have here, okay? I'm looking for the length of CD, which is the whole entire thing, okay? So in this case, I can clearly see I was given my 2 little bits here, and so when I add my 2 little bits together, that would mean the whole thing is 13 inches, okay? That is straightforward use of the segment addition postulate. Okay, let's try another one. All right, so part B says we have, if Q is between R and T, RT is equal to 24 centimeters and QR is equal to 6 centimeters, then what is the length of QT? Okay, please, before you start just adding numbers together, draw this out, because I think we have a little bit of different information than we did in the first one. Because this time when we draw this, okay, so Q is between R and T. So like if this is R and this is T, Q is like right here. Okay, and notice we were given the length of RT. RT would be the whole thing. So I'm going to go ahead and draw like a box here to show that I'm taking the whole thing. So the whole thing is actually 24 centimeters. There it is. And then QR, so that would just be this part right here, 6 centimeters. Now you can see what's going on. Okay, I actually know the length of the whole thing. I know part of it is 6. So what is the other part got to be? Okay, think about it for a second. What would you do to figure out the length of this? What I would do is I would do 24 minus 6. That would tell me that this is 18, which would make sense to me, right? Because if I added 18 and 6 together, that would give me the whole length, which would be 24. So the length of QT is 18 centimeters. So that diagram is so important to these problems. Please make sure you are using it. All right. Okay, so here's a little blast from the past with algebra. All right, so we're going to throw some x's in here and set up some equations to solve. It's really cool how these equations come together with the segment addition postulate. So again, I've got a scenario. P is between L and A. Again, I'm going to draw a diagram because that's the easiest way for me to see what is going on. So here's L, here's A, P is somewhere in between these. Okay. All right, PL, the length of PL is x plus 4. So here's PL right here. So I'm going to say that this is x plus 4. And then I also have PA is 2x minus 1. So I'm going to put that over here. So 2x minus 1 represents PA. Okay. I also have a length for all of LA. So that would be the whole entire thing right here. Is going to be 5x. Interesting. So first of all, when you're setting up these equations, just think about what is the relationship between all the segment pieces you have. And what we know is that whatever the length of LP is and whatever the length of PA is, when we add these two together, we would get the length of LA. Okay? And these expressions are representing the lengths of all of these segments. Okay? We just don't know what X is right now, so we don't know what the exact lengths are. So we can set that up in an equation because notice what we just said. We said this plus this was going to equal this. That's an equation, okay? Because down here I can write x plus 4 plus 2x minus 1 would equal the whole thing. That would be 5x minus 3. And hey, that's something we can solve, okay? Let's go ahead and solve it out. So combine like terms, first of all. So they're on the same side of the equation, so there's no need to do opposites. We'll just combine them. So x plus 2x is going to be 3x. 4 plus negative 1 is going to be 3. That's going to equal the other side here, so 5x minus 3. All right, let's go ahead and combine our x's here. So I'm going to go ahead and move the smaller one over to the bigger one, so I'm going to subtract 3x from both sides. So 3 equals 2x minus 3. And then we can add 3 to both sides. So that would give me 6 equals 2x. Okay, and then go ahead and divide both sides by 2. So I come out with x equaling 3. Okay, so that was step 1. We know what x equals now. Okay, since we know what x equals, we can now actually plug it into our equations to figure out how long each of these segments is. So if I plug 3 in for x, 3 plus 4 is going to be 7. So the length of LP was 7. Okay. If I plug 3 in for x here, 2 times 3 is 6, minus 1 is 5. So the length of PA is 5. And if I plug 3 in here, 5 times 3 is going to be 15, minus 3 is going to equal 12. And look, it all works out. 7 plus 5 equals 12. That's exactly the relationship I was looking for. Okay. They want me to report the length of LA. So LA is the whole thing. That was the 12 units if you're looking for a length unit. Okay. So take a moment and look over this equation. Make sure you know where I got this equation from. Okay. And then see if you can set it up and solve it. All right. So these are really great problems. Being able to use the segment addition postulate with some algebra to solve for an unknown. All right, so that was part of our target. Notice the other part of our target was to use the definition of a midpoint also to find lengths of segments, because midpoints are really nice. They give us some good information, because a midpoint divides a segment into two congruent pieces. Okay, and this definition is on your notes as well. Go ahead and take a peek and make sure you know where it is. Okay, because a midpoint, yes, it's in the middle. Yes, it's the center of a line. That's all true, and that's very important. Okay, but the cool thing is if it's in the middle of a line, that means it's dividing it in half. And if it's dividing it in half, that means those two halves are the same. So they would be congruent, which is our geometry word that means the same. Okay, so take a look down here. Okay, B is clearly a midpoint of segment AC because it's dividing the segment into two congruent pieces. So let's see if we can do a problem with that. All right. So question 6 says, given that M is the midpoint of RS, complete each statement. Okay, so we should draw a diagram, right? Because I said that like a million times. And so it's really important to make sure that you know exactly what's going on. So RS, now M is the midpoint, so I'll go ahead and make sure I put that right in the middle between those. Okay. All right, if RS, which would be the whole thing, is 10, they want to know the length of SM, which is this part. Well, let's think about it. So if the whole thing is 10, if this is a midpoint, that means both of these are halves, right? Which means that each of these must be 5 apiece. So SM is 5. All right. Change of scenario. What if RM, which is this part right here, is 12, and MS, we want to know what the length of that is, and we want to know the length of RS. Okay. So again, M is a midpoint. Remember that it's dividing it into halves. So if this half's 12, if M is a midpoint, that has to be 12. Which means the whole thing would be double of 12, or 12 plus 12, which would be 24. So RS length is 24. Okay. All right, let's go ahead and do a little bit of checks of understanding, okay? So let's say we have points D and E. They're aligned with a ruler. Point D is at the mark for 4.5 centimeters. The distance between points D and E is 3.4 centimeters. At which two marks on the ruler could E be located? Okay, so let me draw out a little ruler here. Okay, so let's say this is the mark for 4.5. Okay, and we want point E to be 3.4 centimeters away from this. Okay, so that means that, let's say I went 3.4 centimeters this way. Okay, if I want this length to be 3.4, there we go. Then that means I would do 4.5 minus 3.4. This would make it, what, 1.1? So this could be my point E right here. Okay. But who said I had to go lower? Maybe I went higher. Maybe the distance from here to point E is the 3.4. In which case I would want to add that to make point E. So you would want to do 4.5 plus 3.4, and that would be 7.9. Okay. So these are my two answers, 1.1, 7.9. All right, point N is the midpoint of FG. If Fn is 2x, what expression represents FG? So let's draw that diagram again, just to make sure I know what's going on. So FG and N is a midpoint, which means it's right in the middle here. Okay, and they told us Fn is 2x. Okay, which means if this part's 2x, this part would also have to be 2x, right? Oh, which means if I'm looking for FG, which is the whole thing, that would have to be my two halves added together. 2x plus 2x equals 4x. That expression represents the entire FG. Okay. All right. Reason abstractly, does array have a midpoint? The quick answer is no, because array goes infinitely in one direction, so there's no way you can know where the endpoint is. An example that illustrates the segment addition postulate, I'll allow you to go ahead and make up your own, but something along the lines of, here's a segment, and so I know that this part plus this part equals the whole thing. Okay. All right, open up part 2 of our videos for the next part of